Hello, and welcome to a video on Exponents Part 1, brought to you by the Answer series. In this video, we will be looking at exponential expressions. The first thing we need to do is remember our laws of exponents. So remember that a to the m times a to the n is a to the power m plus n. In other words, if the bases are the same, the base stays as it is, and I add the exponents. In exactly the same way, a to the m divided by a to the n is a to the power m minus n. If I've got a to the m to the power n, in other words, two exponents next to each other, I multiply them and I get a to the power mn. ab to the m, one term inside the bracket, then the exponent belongs to both of those bases. So ab to the m is a to the m times b to the m. And in exactly the same way, a over b to the m is equal to a to the m over b to the m. So the m belongs to both the top and the bottom of the fraction. A to the naught is 1, so anything to the power 0 is 1, except for naught to the naught, which is undefined. A to the minus n is 1 over a to the n, and a to the power p over q is the qth root of a to the p. Now these laws of exponents you need to know very, very well. I've got 8 examples for you here. I want you to pause the video. I want you to try these, and then we'll look at them together. In 1.1, 3 to the minus 1 is 1 over 3. 2 to the naught is 1, and a third times 1 is a third. Number 1.2, I've got a fraction to a negative power. So what we do is we invert the fraction, and the power becomes positive. So I get 3 over 2 cubed, and then that power belongs to both the top and the bottom of the fraction. So it's 3 cubed over 2 cubed, and I need to work those out. 1.3, 2 to the minus 1 is 1 over 2 to the 1, in other words, a half. 2 to the minus 2 is 1 over 2 squared, so a quarter. And a half minus a quarter is a quarter. 1.4, I break the 8 up into prime factors and get 2 cubed. And then I've got exponents next to each other. What do I do in that situation? I multiply them. 3 times a third is 1, so I get 2 to the 1, which is 2. 1.5, break 9 up into its prime factors, so 3 squared. Multiply the exponents, and you get 3 to the minus 3, which is 1 over 3 cubed, in other words, 1 over 27. Now, in 1.6, be very careful. I have 2 terms inside that bracket. You may not bring the minus 1 into the bracket at this stage. So you can only have 1 term in the bracket for that minus 1 to belong to everything inside the bracket. So the first thing I need to do is simplify inside the bracket. 3 to the minus 1 is a third. 2 to the minus 2 is 1 over 2 squared, in other words, a quarter. I still have 2 terms inside the bracket. A third plus a quarter is 7 over 12. Now I have 1 term in the bracket. That negative power tells me invert the fraction and the power becomes positive. So I get 12 over 7 to the power plus 1. And 12 over 7 to the 1 is just 12 over 7. In 1.7, this bracket to the minus 2, I can take to the bottom, and it becomes 4x to the power 2. The 4 has an exponent of 1, so it stays at the bottom. X to the minus 2 can go to the top, and I get x squared. The next thing I do is I square this bracket and I get 16x squared. And now what happens? The x squareds cancel. 16 times 4 is 64. What am I left with on the top is 1. So my answer is 1 over 64. In 1.8, I've got a bracket to the power a half. That half belongs to each of the bases inside the bracket. So 9 to the half is the square root of 9, which is 3. This becomes x to the half. And then this is y squared to the half. Multiply your powers and you get y to the 1. In other words, y. Take the numbers. 3 times 4 divided by 6 is 2. Then take the base x. X to the half times x to the 3 over 2. I'm multiplying, so add the exponents. I'm dividing by x squared, so subtract the 2. With the y's, this is y to the 1 times y to the minus 4. So add the exponents because you're multiplying, and then you're dividing by y to the minus 2, so subtract minus 2. Simplify the exponents, and you then get 2. X to the naught is 1, and y to the minus 1 is 1 over y, and so I get my answer 2 over y. I've got 3 more examples for you here. I want you to pause the video. I want you to try these 3, and then we'll look at them together. In the first one, what I do is I break up all these bases into their prime factors. So 25 is 5 squared. 36 is 4 times 9. Go further, so it's 2 squared times 3 squared. 81 is 3 to the 4. 30 is 6 times 5. Go further, and I get 2 times 3 times 5. 2 powers next to each other, so multiply them. This n plus 1 belongs to both the base 2 and the base 3, and we multiply the powers. The 3 to the 4 just stays, and this 2n belongs to each of those bases. I then collect together the like bases. So they're the 5s. I'm dividing, so subtract the powers. Here are the 2s. I'm dividing, so subtract the powers. And then here are the 3s. So what I do is I take 2n plus 2. I'm dividing by 3 to the 4, so I subtract 4. I'm dividing by 3 to the 2n, so I subtract 2n. Simplify your exponents, and then you get 1 for 5 to the naught. 2 squared is 4. 3 to the minus 2 is 1 over 3 squared. In other words, 1 over 9. And I get my answer of 4 over 9. In 2.2, 2 to the n plus 1 is 2 to the n times 2 to the 1. So what I do is I take out a common factor of 2 to the n. I've got 2 terms on the top, so I take out a common factor. I'm left with 2 to the 1 minus 1. Okay? On the bottom, I've got 2 to the n times 2 to the minus 1. So what I can do there is I can cancel the 2 to the n's. So I'm left with 2 minus 1 on the top and 2 to the minus 1 on the bottom. 2 minus 1 is 1. 2 to the minus 1 I can bring to the top, and it becomes 2. And 1 times 2 is 2. The last one, let us have a look at it. This is 3 to the x times 3 to the 3, and this is 3 to the x times 3 to the 2. I'm going to take out a common factor of 3 to the x. I am left with 3 cubed, and then I'm left here with plus 2 times 3 squared. At the bottom, this is 3 to the x times 3 to the minus 1. So when I take out a common factor of 3 to the x, I'm left with 1 plus 2 times 3 to the minus 1. These 3 to the x's cancel. And then I simplify this bracket, and I simplify the bracket at the bottom, and then I work with the fractions, and I get an answer of 27. Thank you for watching this video, brought to you by the Answer Series.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.